Alright everybody, we'll be performing part A, PCR, for lab number 6. And Yunghua is on behalf of all of you doing the experiment. So, and she will be following table 1 over here, largely to set up the PCR reaction. Please go ahead.
Yeah, I just literally follow this direction like Dr. Jia said. So first one, I'll add.
Show the PCR tube.
Yes, we use PCR tube is smaller than what you see usually. This final volume is 50 microliter we'll use today. So I'll put buffer first, which is 10 microliter. So this is buffer. Then I will add the DNTP 1 microliter. This is DNTP. I don't know if you can see well. Then we should add 4 then reverse primer. Each of will be 2.5 microliter. This is 4. This is reverse. Then we add our template, which is 2 microliter. It's the same template, it's a different tube. We separated, so it's still 2 microliter total. Then we'll add the DMSO is.
Oh, that's okay. This one we're not adding.
Oh, okay.
But you're adding.
And finally, we will use water, but we use the water for filtered water for 30.5 microliter.
Get that element, you can use pen.
So once you add all of them, we only missing our enzyme. So enzyme has to keep in -20. So Dr. Zia just grabbed enzyme from freezers.
Yeah, so this is a benchtop cooler. So this thing, we keep it in the fridge, but then when we're ready to use, we can take it out. And it can sit on the bench for an hour or 2 and yet keep the temperature low for these enzymes. Alright, so this is blue one.
So I'll finally add the enzyme right here. So you don't want to touch at the end of this tube, because it has enzyme and it's very sensitive for temperature.
And when you finish, we immediately return this back to the freezer.
We need to do centrifuge.
So Yonghua just quickly mixed everything in the tube, and then we're gonna do a quick centrifuge, bring everything down to the bottom. That's okay.
No balance. So, because it's a small tube, we use different type of centrifuge, and probably like 30 seconds to 1 minute spin.
Yeah, it's just a quick high.
Okay.
Yeah.
Hi. So this is a PCR machine. So we use BioRed thermocycle machine. So Dr. Zia already set up our cycle. So our cycle is a fusion, and he set up all proceed.
Right, according to what's listed on the lab menu, right?
Mm-hmm.
So
Then how it works is when you open it, you can see all this spot. Unless you assign specific command, it'll be all spot will be same. So you can put any spot. So we have one reaction. So you can put it right here, and you can close it.
okay.
Then it already assigned for fusion our cycle. So what you can do is run, and it asks how many volume.
Yeah.
The manual is 50 microliter, but we cut in half for 25 microliter. So it is good. It's okay. So it'll take 1 hour and 22 minutes to finish. So we're just gonna wait for 1 hour and 22 minutes.
Right, and the next step would be to do what you've done in the last experiment, run the agarose gel of this PCR product, and then we'll perform part B, which is to purify the PCR product using gel extraction. We'll see you in the next video. Okay, so this is again the lab number 6. We finished the PCR reaction. We ran it on the agarose gel just like we did in lab number 5, and this is the final gel. So we're gonna now take a picture of the gel like we've done previously in lab 5. We will use the gel documentation system. So transfer the agarose gel onto the special plate, slide it in here, and basically shoot it. This will take 1 minute. So the reaction worked. The program is adjusting the brightness. Okay, so we have 2 of them side by side, one on each side of the marker, so both are working, and it's about roughly the same size. So we'll later on extract one of them only. Okay, so we will save the gel picture, and you will be getting the picture on the email. Okay, so now we finished taking the picture. We transfer the gel onto this area where we can visualize the bands, and this time we have to do something of the gel band. So it's the extraction part. It's how we purify the DNA. So now I'm going to turn on the UV. I have the protection gear on, and Yonghua turn off the lights so that we can see the gel. You can tell, you know, on this machine you can see the bands, right? So we will use this tool to basically cut out the piece I want to purify. Okay, so I'm gonna, Yonghua will hold it, I'll do the cutting. So if you get a little closer, the piece that I want to purify is on my tool, and the rest is still sitting on there, missing basically the only piece. And I'm going to transfer my piece into a pre-weighed tube very carefully and tap to the bottom. Okay, so that's it for this step. Okay, so now we're moving back to the bench. This is the tube, you know, with our agarose gel piece inside. So we have weighed this piece and know exactly how much it weighs, and we're gonna add 3 times of that weight worth of the volume of this buffer, the capture buffer. Okay, so we are using a different kit than what's written in the protocol, but the principles are the same. Okay, so basically this capture buffer will be added to our sample. Okay, and then we'll incubate this mixture in a heater around 60 degrees Celsius, and then this will basically help dissolve this piece into this buffer. Okay, and that will take about 10 minutes. So this is preheated to about 60 degrees, and our sample will be sitting in here, and we'll be tapping it occasionally to help dissolve it faster, but the whole process will take a few minutes. Okay, thank you. Alright, so the incubation time is finished. The chunk has dissolved in the liquid. I don't know whether you can see it, but it's been dissolved. Okay, so we just turn off the heater. Now we're gonna get a quick spin, right? So that we bring everything down to the bottom. Then we can start the transfer. Start the next step. So just very short spin. Okay. So here, that's our solution, and we have our spin column ready. So the spin column has 2 parts, right? So this is from the kit. The bottom part is just regular tube. The top part is the sophisticated portion. So our sample will be loaded into this top part, and at the bottom you have a little membrane. Okay, little membrane. So this membrane is capable of capturing the DNA sample. Okay, so when our solution is loaded and we're gonna put it in here, we do a little spin in this machine, and the spinning will bring everything down passing the membrane, right? So the liquid will all flow through, but the DNA sample will be captured, will be trapped at the membrane over here. So okay, so everything else will flow through, DNA will be captured over here. Okay, and then we'll later on do some other steps to wash the DNA sample with other buffers, right? And then eventually elute it off here to obtain a pure DNA sample. Okay, so that's what we're gonna be doing. So transfer this liquid into the spin column. Again, the kit we're using is slightly different than the one described in that menu, but they all work in a similar fashion. Okay, so transferring the liquid into the spin column. so you have counterbalance over here. I'm gonna cap it. 13,000 RPM for about, in this case, we can do 30 seconds or 1 minute. Either one works. Do 30 seconds. Okay. So for this part of the experiment, we'll have to do it in this lab anyways, because in the teaching lab we don't have a desktop centrifuge, right? So, and we needed it. So here is the spin column, right? The liquid is now been transferred to the bottom. The top is free, but DNA is again trapped at the membrane at the bottom of the top portion. So we're gonna dump out the flow through in a waste container. Right? So we'll put this thing back at the top, and we'll transfer in some washing solution, washing buffer. Okay, so that's the wash buffer. This wash buffer has a lot of ethanol in there, and this will not dissolve the DNA. Okay, it will not elute the DNA off the spin column. Okay, now it's again added at the top. We'll do a quick spin like the last time. This time we'll let it run for 1 minute, and this will wash the DNA sample. Okay. In the meantime, we'll have another clean Eppendorf tube prepared, and we'll label it. So this one will be the one that we'll elute our samples into, and we'll keep it for the next experiment. Okay. So because we are amplifying the P1B gene, I'm gonna say P1B PCR on top. Okay, I'll do the side as well, and maybe put more information. Okay, and then hopefully this will be ready in a few seconds. Okay, so again, the liquid is at the bottom. We can dump it out, and we can now also discard this whole tube. Okay, so now this portion will be transferred on top of the clean tube, which we just labeled over here, and on top of this spin column, we'll add our elution buffer, which is basically water. You can use pure water as well. Okay, so this will dissolve the DNA, and when you spin again, the DNA will elute together with the liquid to the bottom tube. Okay, I'm adding about 30 microliters, and do it right on top. Okay, don't touch the membrane, but make sure your liquid is added on top, and this should be sitting here for about 1 minute so that you give enough time for the liquid to interact with your DNA to dissolve it, and then we can do a spin to bring the DNA sample down to the clean tube. Okay. I'll put it in here. Close it. Okay, wait until this is 1 minute, then we'll start the spin. Okay, so it starts spin for 1 minute at 13,000 RPM. So that's our tube. You see the liquid is now at the bottom of the tube, so the top portion can be now discarded, and this labeled tube is what we'll be saving for our next experiment. Is the product of our PCR reaction, which is now purified. Okay, all right, that's it. Thank you, and you will be getting the job picture through email so that you can work on your lab report. Okay, bye.